Alright, today we're going to go through the unit circle on this video. And so we're going to start out with that being 0 degrees, this being 90 degrees, this being 180 degrees, and this being 270 degrees. Now in that, we also know that this is 360 degrees. And so our special angles in quadrant number 1 are 30, 45, and 60 because we have these triangles that are, I'll make this one 45, 45, 90, and the 30, 60, 90, which is 1, square root of 3, and 2. Now for the 45, 45, 90, we've done this as 1, 1 in the square root of 2. But for the purposes of the unit circle, I'm going to change this to be the square root of 2, the square root of 2, and 2. Because if we multiply all of these sides by the square root of 2, we get a similar triangle. And so when we do this, really this unit circle, everything has a radius of 1. So this point over here is going to be at 1, 0, and this one is going to be at 0, 1, and at negative 1, 0, and at 0, negative 1. And anytime we have this unit circle, the sine is the same as the y value, and the cosine is the same as the x value. So if I ever ask you what is the sine of 0, the answer would be 0. If I ask for the cosine of 0, the answer will be y, because the y value is the sine and the x value is the cosine. So as I go around the circle, since the cosine is the x value, that's going to be the square root of 3 over 2, and the y value, which is the sine, is going to be 1/2. And then this one is going to be the square root of 2 over 2 and the square root of 2 over 2. And 60 is going to be square root of 3 over 2, comma, let's try that again. It's going to be 1/2, comma, the square root of 3 over 2. So the 2 stayed the same in all of these, and the numerators just kept going up by 1 for the y values and down by 1 on this side. So as we go around this, we already did this in 6-1, where 120, 135, and 150, and 210, and 225, and 240, and then in quadrant number 3 we had 300, and 315, and 330. So now, when I'm looking to get these into radians, we're just going to multiply each one of these by pi over 180. So 0 is still going to be 0. 30 is going to be pi over 6, pi over 4, and pi over 3. 90 is pi over 2, or 1/2 pi, as we've been talking about. 120 is 2 pi over 3, 3 pi over 4, and 5 pi over 6, and this one is just pi. And I'm just doing this by multiplying by pi over 180 for each of these, And remember, the same reference angles all have over 6. Five pi over 4. This one will be 4 pi over 3. And 3 pi over 2. Then we got something with pi over 3. And then pi over 4, so 7 pi over 4. And then 330 is 11 pi over 6. And 2 pi. So, now if you notice, because of symmetry, these points should be at the same one, but over here, the x value is negative 1/2, the y value is still positive. So, this point and this point match up, except for the x value is now negative, and that will happen for everything else in the second quadrant. Third quadrant, now both the x and the y are negative. Until we get to 0, -1. And then finally we have over here the x is positive, the y is negative. So this will be 1/2 comma negative square root of 3 over 2. Square root of 2 over 2 comma negative square root of 2 over 2. And square root of 3 over 2 comma 1/2. So for any one of these problems, you can basically have the sine being the x value and the cosine being the y value. So the sine on that page was the y value, the cosine was the x value, and we didn't talk about the tangent, but the tangent is always the y value divided by the x value. So we should probably keep doing the problems the way that we've been doing it. So if I ask for the sine of 7 pi over 4, first we figure out that that's 1 3/4 pi, which means 1.5 pi, 2 pi, down over here. So the sine is negative in the fourth quadrant. Then we get our 45-degree angle, 1 in the square root of 2. Sine is opposite over hypotenuse, and that is my answer. For those of you who couldn't read my writing, here's a much better look at this, as well as this one should be 0 and 360, but everything else is on there in much more neat fashion. Alright, after you've watched the video, try the 2 worksheets. Let me know if you have any problems.